Hey everybody, Mrs. Bodechon here. So we're going to look at 3B. It says, I can develop and use models of chemical equations to illustrate how the total number of atoms and how mass is conserved during a chemical reaction and chemical change. So the very first thing you see on your paper is going to be this chemical equation, and it's asking you a whole bunch of questions about it. So let's take it one question at a time and make sure we understand. So the first one says, how many magnesium atoms are on the reactant side? Well, the first thing you need to know is which side's reactants and which side's products, right? So the reactant side is going to be on the side where it's being added together, right? And then the product side is what you end up getting in like in the end of the equation. So if this was a math problem, if this was like 2 plus 2 equals 4, right? The product would be 4. You guys know product is like if you multiply something, we call it a product, the answer. If you want to think about it that way, by all means go ahead, because usually what you're actually producing from the chemical equation is the product. So this would be the product side in this case. We're combining magnesium and oxygen, and this is what we're getting out of it, magnesium oxide. So how many magnesium atoms are on the reactant side? Well, I'm looking at my yield sign to the left. So all of this is going to be my reactant side. Magnesium is right here. And I do have a subscript here. It's 1, okay? I don't have to write it because it's understood, just like in math, you don't have to write 1, but there is a 1 there. If I have a coefficient, which is this large number in front, what that does is it uses the distributive property over, and it's being multiplied by the subscript. So in this case, I have a subscript of 1. So 2 times 1 is 2. So I have 2 magnesium atoms. And then it says, on the product side, how many magnesium are there? Well, I'm going to do the same thing. I have a 1 right here that's understood that I don't really have to write. So 2 times that 1 is 2. So I have 2 magnesium atoms on the product side. And it says how many oxygen atoms are on the reactant side. Well, here's my reactant side. Here's oxygen. Now I do have a subscript of 2, but there's nothing in front of oxygen. Again, that's an understood 1. Okay, we don't really have to write the ones. That's just understood. So 1 times 2 is going to give you 2. So I have 2 oxygen. How many are on the product side? Well, here's my oxygen on the product side. Now the 2 is in front of this whole compound. So this 2 is really going to be distributed right here to magnesium and right here to oxygen. It gets distributed as far as the compound goes, all right? Until basically you get to a plus sign or a yield sign. If you want to think of it that way, that's an easy way to do it. So I do have an understood 1 here as a subscript. So 2 times 1 is 2. So I have 2 oxygen there. How many elements are in this chemical reaction? It's going to be 2. I only have 2 elements. I'm dealing with magnesium and I'm dealing with oxygen. Only 2 elements, although I have multiple atoms of them, right? Is this chemical equation balanced? I know it's balanced if I have equal number of atoms of the same elements on the product and the reactant side. So I have 2 magnesium, 2 magnesium, 2 oxygen, 2 oxygen. Because they're the same number on both sides, it is a balanced equation. Okay, and the last one says, draw a model to prove that the law of conservation of mass is true during this reaction. So here is the model that I'm going to show you all. So in order to draw this correctly, you need to draw it in circles, okay? And you can use different colors, you can use patterns. If you don't have colors, you can make like polka dots or stripes or whatever inside your bubbles to indicate different elements. Because if they look the same, we consider them the same. For example, I have 2 magnesium, so they're both going to be this dark red color, all right? Now, I drew them not touching because they're elements. And this is saying I have 2 magnesium atoms, so they're separate, right? So here's one of them and here's the second one. And then the addition sign. Now I have 1 molecule of oxygen and they're a pair. So I have to draw them together because it's a molecule. they're chemically combined. So I do have to draw them touching now, and I only have one molecule of this. What this is saying is magnesium comes in ones, and oxygen too is going to come together, okay? So anytime I draw this, I'm going to make sure that I draw my magnesiums together. So if I wanted to add another one, I would have to draw my oxygen together. If I wanted to draw another magnesium, I would draw it separate, okay? Because these come in ones and these come in pairs. But on the other side, my product side, this is now what's happened after they've chemically combined. So once something chemically combines, it changes, right? It's no longer the same. So in this case, we have two compounds of magnesium oxide. So I have one magnesium and one oxygen each, but I have two of those, okay? So do you see how I did that? One magnesium, because there's a one here, oxygen, there's a one here. So I have one bright red, one dark red, and then I have a second one because I have two of these. So I have one bright red, one dark red. And notice I drew them touching because that is a chemical compound, but I don't have all four touching because I have clearly two separate compounds there, okay? All right, now if we look at this one, this one is saying, I'm trying to get a good spot for you guys to see. It says, balance the following chemical equations and draw a model proving the law of conservation of mass. So here we have aluminum and oxygen, and it's decomposing, right, into aluminum and oxygen separate. So the model that I've drawn, this is the compound that you're seeing here. So my oxygen are going to be red, and aluminum is going to be gray. Notice they're all touching because this is a chemical compound. It's chemically combined, so my dots do have to be touching in order to signify that. My colors are different. Oxygen is red, aluminum is gray. Make sure that you're distinguishing the difference between them, right? Now, if I draw it over here, just going to move this up. If I draw it over here, I only have one aluminum, one gray dot, and I have two oxygen, so two red dots. Now, is this balanced? No, it's not. I have two gray, I only have one, right? I have three red, I only have two. So now we have to balance it. You can do this in two different ways. You can balance it with this picture, right? This model that we have going on here. So I can do that. I can say, okay, I clearly need two gray. So let's add another gray dot. And then I can say, okay, now the grays are balanced, but I have three red and I only have two red. So let's add two more. I have to add them in increments of two because they come together. They're chemically combined. So I can add two more, right? That would give me four. But I don't want four. I only wanted three. So I can't do that. But they only come in twos. So what do I have to do? I have to add another one of these, right? I have to have another aluminum oxide to my to my reactant side over here in order to make this work. Now I have four gray, so I would have to end up putting four dots, 1, 2, 3, 4, and then I would have 6 red. So what I can do is I can do 3 pair of red. So let me show you what that really looks like. This is what it looks like in the end. So I end up with 3 pairs of the red, 4 gray dots, right, which are just 4 aluminum, and then 2 compounds of the aluminum oxide. Now, in order to get the correct answer, all you have to do is count up each one you have. I have 1, I have 2. So I put the coefficient, the large number in front of 2. Now, how many gray dots did I have to add? I had to add 4. So I put a coefficient of 4 in front of aluminum. How many pairs of oxygen did I have to do? 1, 2, 3. So I put a coefficient of 3 in the front. Now, if you don't like doing it this way, or it's confusing, or if you just find this way easier, you can do it this way. So let me show you this way. This way we write like a line down at our yield sign, and we're going to write how many of each atom we have on each side. So our starting, we have 2 aluminum and 3 oxygen. Now just go ahead and write the same thing on this side, aluminum, oxygen, and see how many you have on this side. So we have 1 aluminum and 2 oxygen. Clearly we're not balanced, right? So you want to start with whatever one is lower, and you want to make that one increase. All right, so we're going to go ahead and start with aluminum. Aluminum is lower on this side. It only has 1, on the side is 2, right? So we need to make this 2. How can we do that? We can add a coefficient. You can never add a subscript, okay? So just note that down somewhere. You cannot add, you cannot take away subscripts. The only thing that you can change is a coefficient, the number in front. So what I can end up doing is I can add a coefficient in front of this aluminum, and I no longer have 1, now I have 2, right? And that's all I've changed so far. Now, my aluminum is balanced, awesome, but my oxygen is not. I need this oxygen to be 3. So what can I times 2 to be 3? I can't times anything by 2 to be 3, but I still need it to increase. So let me go ahead and add a 2. And what that 2 does is 2 times 2 equals 4. So now I have 4, but I really wanted 3. So what I have to do now is I have to go back over here to this side and say, okay, I need to increase this, right? So in order to increase this, I have to increase the whole thing. And that's okay, all right? So it has a 1 here. So what can I put in front? I could put a 2. So if I put a 2 in front of that one, now I have to change everything that affects, because remember I have to use the distributive property. So 2 times this 2 equals 4 aluminum now. 2 times this 3 equals 6 oxygen now. So now I'm just really out of balance. And this may seem like you're doing it wrong because you're not getting it very quickly. You're doing it just fine, you guys. It's just going to take a second to get the right answer, okay? Now you got to fix your aluminum because you have 4 over here and you only have 2. So if I erase this 2, what can I put here to make it 4? I could just put 4, right? So I could just replace this and put a 4 because 4 times that 1 is going to give me 4. So that's going to fix my aluminum. I have 6 on this side. I really need 6. So if I erase this 2, what times 2 will give me 6? 3. So it's going to end up looking like this. I'm going to switch these two. All right. Oops. And that should be a 4. 4. There we go. Ha! I edited it for you guys. All right. So this one should be a 4. So 4 aluminum and then 6 oxygen. Now it is balanced and we are done. So your final answer, you guys, is this right here. It's the actual equation with the correct coefficients. This down here is your work. Okay. All right, guys. Thanks. That was 3B. Bye, everybody.